Alright, this screencast is the first in several installments on doing stoichiometry. And stoichiometry is the same thing as reading a recipe and being able to predict how many products you can make or determine how many reactants you need. So how many starting things in your ingredients list and how many end results can you make. Alright, so here's one, this one's my favorite. I mean, chocolate chip cookies. Who doesn't love chocolate chip cookies? So you have a recipe and you have ratios in that recipe, and you can tell by looking at this recipe that if you put 6 tablespoons of brown sugar or 1 egg, you will be able to make out, what's it say, 24 2-inch squares. So if you follow this recipe accurately, you know how many things you're going to make. So chemistry has a similar example, and it's called stoichiometry. So things that you need to know to be able to do stoichiometry is you need to remember mole conversions, going from grams to moles using the molar mass on a periodic table. You need molar volume sometimes if they ask you for liters, and 1 mole is 22.4 liters. You might need to know Avogadro's number if they ask you for the number of molecules or atoms. Molar mass, again, and you will need to be able to balance an equation, because unless you have a chemical equation that's balanced, you don't know the correct ratios. So anytime that you're doing a stoichiometry problem, the first thing you should check is to see if your equation is balanced. Alright, so here are some starting options and stopping points. You can be given mass and asked to find mass. You can be given volume and asked to find volume. You can be given molar concentration and asked to find molar concentration. You can switch up the paths. You could go from mass to volume. You can do lots of different substances there. Alright, so here is what is mole ratio. Mole ratio is the first thing that you need to be able to do when you are solving a stoichiometry problem. Is you need to be able to read the conversion factors in the balanced chemical equation to help you understand how many moles you will make. So mole ratio is a conversion factor that relates the amount of moles in any two substances involved in a chemical reaction. So looking at this example, you see that you have 2 Al2O3 and you have 4 Al and you have 3 O2. Okay, so we can then pull out the mole ratios, and mole ratios usually just compare two things. So you can pull out that 2 moles Al2O3 are also equal to 4 moles Al. You can pull out 2 moles Al2O3 are equal to 3 moles of O2. And you can pull out that there are 4 moles Al are equal to 3 moles of O2. Now you can switch these all, and you can have the 4 moles Al over the 2 moles Al2O3, and you can have the 3 moles O2 over the 2 moles Al2O3, and the last one as well, you can do 3 moles O2 over 4 moles Al. They're all equal, so you can switch what's on the top and the bottom in order to make it fit into your problem. So here's a sample problem. When you are being asked to find, they give you an equation, and they might say when you have 2.3 moles of nitrogen, how many moles will you make of NH3? So this one is asking you to go from moles to moles. Okay, so we start with the number that they give us in the problem, 2.3 moles N2, and we're going to do a conversion factor just like we did way back in the beginning with dimensional analysis. The unit that we start with has to go on the bottom of the next fraction, and then the unit that we're looking for would go on the top. So in this case, we need to come up with a conversion between nitrogen to NH3. So in our balanced equation up there, we have how many moles of N2 here, and we have how many moles of NH3 here, and the answer is we have 1 mole N2 and we have 2 moles NH3. So in our equation, in our fraction, we're going to put 1 mole N2 on the bottom and the 2 moles NH3 on the top, and then you just multiply, and because we're done, we found moles of NH3, so it is 4.6 moles NH3. Again, sig figs, follow the rule of how many you start with to how many you end with. You keep the same. Alright, so same equation as above. Let's try another problem. You want to use up all 1.75 moles of H2. How many moles of N2 would you need? So we're going to start with the 1.75 moles H2, and in our next fraction we're going to relate moles of H2 to moles of N2. So we can see that we have up here in the equation we have 3 moles of H2, and we have only 1 mole of N2, so we're going to put the 3 on the bottom and the 1 on the top, and then you solve. This problem is one fraction, and we know that it's one fraction because it's moles to moles, and we can do that all in one step. Some of the problems that we're going to look at in the future are not necessarily one step.